This is page 12 of the I/O notes, and section 3.2, and it is nested interrupts. I mentioned this briefly when I was talking about the interrupt or the exception handling mechanism. So every exception source, which would include IRQs, is assigned priority, and let's just talk in terms of IRQ or ISRs, IRQs. So higher priority IRQs can interrupt lower priority ISRs. So you're running an ISR for a lower priority interrupt request, and a higher priority request can still be allowed through. So that's what a nested interrupt is. So here's an illustration of that. So here's our main, our application, and we're running it instruction by instruction, and our control flow, which again is just the sequence of instructions that gets executed. It's running, and an interrupt comes in, and so we have a low priority interrupt request. So this is the preemption point. So when you're running code and it gets temporarily suspended and then resumed, it's been preempted. Well, really, I guess when it's suspended, that's when it's preempted. So that's our preemption point. And so the ISR for that low priority IRQ. So let's say that this is interrupt request number 0. So this is going to be IR0 that's associated with it. We're executing that, and then IR0 gets preempted. I'm running out of room here, so this is going to be a high priority interrupt request. So let's say that's number 1, and so we're going to run the ISR or the handler for that particular request. So here's our control flow. When that returns, then we will come back to where ISR0 had been preempted. We'll resume it, and when we finish it, then we will go back up to this point where our main application was preempted and resume running it. So that's an example of one level of nesting. And you could have as many levels of nesting as you have priority levels, so something like 64 deep. You could run out of stack space because it's saving the context on the stack every time it does that. So you have to make sure that your stack is configured to be large enough for depth of nesting you might need in terms of interrupts, but also in terms of your application nesting depth. So here's just a couple ISR rules of thumb. You're probably not going to be writing like fault handlers. I mean, it'd be cool if you did, but more likely that in a co-op you might be asked to write the ISR for an I/O device. And number 1 is keep it short. So when I graduated with my master's, I'd worked on compilers for digital signal processors. So this compiler could be targeted at different architectures of DSP. I just did the instruction scheduling. I was part of a bigger team. Anyway, so my supervisor knew the president of this company in Nova Scotia, which was started as a center of excellence, and it was meant to connect university research faculty with industry. And so we would get contracts, and one of our contracts, so by the time I was there, it was turning into like a for-profit, just a regular old business. One of our contracts was with Spar Aerospace. They're the ones that developed the Canada arm and the Canada hand, I guess, the dexterous manipulator that goes on the end of it. You can see one of them actually through a glass window in the foyer at their facility in Brampton. And so the contract we were working on, this was for the Dutch Navy, and it was to detect surface skimming missiles. And it was using infrared. Radar does not work well at wave height. There's a lot of scattering, and you just get back like a cloud or fog or whatever if you're trying to read it. So instead it was using infrared because these things are moving at like Mach 1, Mach 2, and they really heat up. So anyway, I was working on an I/O driver for a piece that was receiving this infrared data and then transferring it from one location to another board. And so I developed the ISR. This was with VxWorks, and we did a code walkthrough with some of the people from Spar. And one of the people there, the project manager, I guess, his name was Mata Bishun. I think he might have grown up in India. He was an entertaining guy. He had a big bushy mustache. And anyway, so he basically taught me what I know about ISRs. And so I'd done too much processing in my ISR. He said, you want to get in quick and you want to get out quick, and just save whatever needs to be saved into like global memory, and let the application level take care of processing the data that you're getting. So keep it short. That's number one. Number two is pass data out or read it in with global variables. And that would include things like OS message queues and stuff like that. Okay, and number three is ISRs should only call reentrant functions. If a function is not reentrant, it shouldn't call it.